To understand derivatives, we need to know the following basics. What is tangent of an alpha angle in a right triangle? What is tangent line to a curve at a given point? And what is function and how it works? If you already know this, you can skip to my next video solely dedicated to derivatives. First, tangent of an angle. Tangent of an angle is one of 4 elementary trigonometric functions. All these functions, sine, cosine, tangent and cotangent, are simply different ratios of 2 side lengths of a right triangle. To understand derivatives, first of all we need to know what is tangent of an angle. Tangent of an alpha angle is simply a ratio which equals to the side length b, which is opposite to the alpha angle, divided by the side length a, which is adjacent to this angle. We also have to remember that the tangent of the 0 degrees angle equals 0, and the tangent of 90 degrees, the right angle, doesn't exist. Tangent line. Tangent line is a straight line which touches a curve at only one point and is placed at a certain angle. Let's take some curve, for example, and let's say that we want to draw a tangent line at this point. Now let's take some other point which belongs to this curve, and let's call the distance between them delta x. Delta x is a difference between x's from both of these points. Now let's draw a straight line going through both of these points. Next, let's get this second point a little bit closer to our point P. In other words, let's make delta x a little bit smaller. Again, let's make delta x smaller and smaller and smaller until it approaches 0. When delta x approaches 0, our 2 points become one single point, point P. Now this random straight line coming through point P becomes a tangent line to our curve at point P. When drawing tangent lines, the only problem is to find the precise angle, the slope, the steepness of the tangent line. With circles, it's easy. The tangent line is always perpendicular to the radius at this point. And a special case, tangent line to a straight line, is this straight line itself. Functions. Functions are basically formulas which associate each element x, which we call variables or arguments, from set x to only one element y from set y, which is called value of the function. Let's take some example. Functions are denoted the following way. F of x equals, and then you write the formula, or simply y equals, and then you write the formula. Let's take a function f of x equals x squared. On the left side of the picture we can see set x with some examples of x's, and to receive the respective value of y for each of them, we just have to square them. There are many kinds of functions, for example linear functions, quadratic functions, cubic functions, each of them having their own properties. Let's take as an example a linear function, as this is one of the most fundamental types of functions. The general formula for linear functions is y equals a times x plus b. In our example, let the linear function be y equals 2 times x minus 1, or in other words, f of x equals 2 times x minus 1. In our function, the a component equals 2 and the b component is negative 1. In this example, to receive the value of y for each x, we have to multiply each x by 2 and subtract 1. Let's focus for a moment on the a component. It tells us how steep is the graph line of our function. In other words, it is tangent of an alpha angle between the graph line and the x-axis. Okay, but why does component a also equal to delta y divided by delta x? First, let's see an awful formula. Let's start with the bottom part. Delta x, which means difference in x, is some next x minus some previous x. And the upper part, delta y, which is difference in y, equals to value of the function at some next x minus value of the function at some previous x. An example, our previous x will be 3 and some next x will be 4. So we have value of the function at 4 minus value of the function at 3 divided by 4 minus 3. At the end, we can see that delta y equals 7 minus 5, which equals 2, and delta x equals 1. 2 divided by 1 equals 2. Again, this is our a component. Let's go back to the graph and let's mark those 2 points which we chose for our calculations. Point 1, 3, 5, because when x equals 3, value of the function, the value of y, equals 5, and point 2, 4, 7. Let's mark delta y, the difference in values of the function between those 2 points, with blue, and delta x, the difference in x's between those 2 points, with orange. Now, can you see the triangle? To compute a, we simply divide the side length delta y by the side length delta x. And this is also tangent of the alpha angle. In our example, it's again 2 divided by 1, which is 2. Okay, but what does it mean that a component equals 2? It means that if we increase x by 1, value of the function will increase by 2. Thank you for watching and see you in my next final video on derivatives.